Hello everyone, I'm Bradley Sward, Associate Professor of Computer and Information Science at the College of DuPage in Glen Ellen, Illinois. This video today is going to look at the Singleton design pattern. We're going to go over the generalities of the Singleton design pattern, and then we'll do a specific example using C++. So just so we can get this out of the way, there will be no debate upon this, if this is a design pattern, an anti-pattern, the criticisms. I do not necessarily care about them in this video. This video just describes how to accomplish the Singleton pattern and all the problems that Singleton solves. And in my research of trying to find a picture of Singleton, I found this, and I think we can all agree, at least if you're 21 or above, that this is probably, at the very least, something a little more fun, something a little more enjoyable than our nerdy Singleton design pattern. So what is a singleton and why do we care? So a singleton is an architectural design pattern in computer science and computer programming that restricts a class to one single instance / object. So no matter where you are, you could have a giant system, many files, many systems of code working, and no matter where you are, there's only one instance of this object that exists throughout the entire system, no matter what you try to do. You try to create a second one, you can't do it, and if you try to get it, you get the instance, you always get the one true instance. And so the Singleton design pattern answers questions like, how can we ensure that a class has only one instance? I mean, that's what I was just describing. How can we ensure that no matter what you try to do, that you can't screw it up and pull down a second or a third instance? How can the sole instance of the class be accessed easily? We will see that there's we'll create a function that can basically just a getter function that can get this one object. How can we control the instantiation? We will see that we are actually set up a private constructor. Sounds crazy as it is. Like, how can we actually make this thing work if we can't construct the thing publicly? But you will see at the end of this video. How can the number of class instances be restricted to the one and only? We will show that, obviously. How can the global variable be accessed? It's very similar to how can the sole instance of the class be accessed. And so those are the questions we're going to be answering with the Singleton design pattern. So coming down to controlling the instantiation, we're going to hide the constructor, we're going to make it private, and we're going to have this, to be able to still get the singleton out of the design pattern, we're going to define a public static member function that returns, in C++ anyway, a pointer or a reference to the class, to the object that's sitting under the hood. Okay, the key idea, or one of the key ideas to this design pattern, is that the class will be responsible for creating itself in a weird kind of way. It's the chicken versus the chicken before the egg before the chicken. It all just kind of comes together and works. So the private constructor can be called from a public static function. That's what we're going to see when we set everything up here. And then once we have that one singular object being maintained under the hood, we can use a public static member function to access that and get the pointer and do everything we want. We conventionally call this function getInstance. You might see it differently in other programming languages, but in my experience, in my lifetime, I have seen the word, the phrase here, getInstance, that will conventionally get that pointer or reference. And so you would see something like this here, player manager arrow getInstance, as a way to get the object. And then from here, you'll arrow into more, because this is a pointer or a reference. You'll be able to get more information from it. And I'll show you in the example about how that works. And so just to finish up here, the last couple things here. So we have to make sure when we implement this design pattern that we ensure, again, and I know we're repeating ourselves, but just making sure we understand what we're trying to accomplish, that we're ensuring that the one singleton class only ever creates the one instance under the hood. And then we can provide global access to that instance. So it's like, again, so if you haven't said it before, it's like a fancy global object or a global variable. And that's why I kind of preface this whole thing by saying, globals aren't generally not good. And so I don't want to argue, is it, is this a pattern? Is this good programming or poor programming? Let's just get to the point of it, implementing this. And so what we described here, we typically declare all the constructors private, and we provide a static method or a static function that publicly that returns the reference or the pointer to that instance. So we're going to store that instance in the class as a private static variable, and then the instance is created. So it starts out as null, or whatever you want to think of. It doesn't start out initialized. We're going to call it lazy initialization, that only the first time that you try to get the instance, then it will actually create it. So if you never call the function, the class never gets instantiated. And then, so the get function for that first time will create the instance, and every time after that will just return that one instance that was created on the first call. And so here is the UML diagram at its simplest for the singleton design pattern. There's a private constructor that returns the singleton object. There is a private, here's the private constructor. This is the private member variable that, basically the pointer, the reference sitting under the hood. Sorry, I got it all a little mixed up here. And then this is the public function to get the instance of the singleton object. And so again, the foundation code for this is going to be pretty much the same every time in whatever language you choose. I'm choosing C++ again, but just remember that this is the simplest example that I can give you just to kind of get the point across, and that other things such as whatchamacallit here, I thought I had it written down here. Maybe I don't. Nope, I don't. Such as, where did it go? Making things thread safe and other things, like threading and multiprocessing and things like that. All those bigger topics, we're not covering that. We're presuming a single thread, and we're presuming that our program is running one line of the code. Not everybody's going to hit our data from all over the place at asynchronously. So just to keep that in mind. Okay, so let us take a look now at writing this code in C++. Okay, so what I have here is a source.cpp file. It is including iostream and the singleton.h file that has nothing in it just of yet. I just kind of created a basic outline here for what we're going to put in here. So it will run. There's nothing it will run, but we have the simple stuff going here. So we described here that we're going to have a private. Data is almost always private in a class or a structure. So just keep that in mind. But in this case, I'm going to have a singleton, and I'm going to put the pointer up front, and I'm going to call it instance. And so we've discussed that typically we have wherever we find it here, the instance is stored as a private static variable, because right now every singleton class would have its own instance. But whenever you're thinking of sharing a function or sharing a variable across many different places, that's where the idea of the static comes in. Static for a class, for like this, in this case, screams out every member of singleton shares this one variable, as opposed to everybody getting its own version, its own data that stores its own instance of that type. So I have a static singleton pointer called instance that is private. Okay, and that goes here for this top guy. That's my member variable. And so now we also have a private constructor. And for that case, I just put that like that. And I don't have anything in here just yet, but I'm going to follow up and move the example forward. I'm going to go ahead and quick actions. I'm going to set it up in the CPP file. And so there it is right there. And right now I'm going to leave it blank and empty, but I will fill it in a little bit. Okay, and so that is pretty much the constructor. But again, it's private. And the first time I thought about this, like, oh my goodness, this is crazy. How is there a private constructor? But the whole point comes down to this public function that's going to return my singleton pointer. I'm going to call it getInstance. And I'm going to make it static, because a static function can access static data of a class. A static function cannot access cannot access regular non-static data, like if I had a member variable down here called width or something like that. That is non-static. I cannot access that through the static variable. And I'll show you, once we have this whole thing set up, how to make this thing work and how to be able to now access that width variable. But that is pretty much, looking at this, the basics of getting this thing going. I do need to instantiate this. So right here, let me just go over here. Oops, let me open up singleton.cpp. Okay, so this get instance function is where we do the check and balance. I want to return instance. I want to. And I guess, just to be clear, just to make sure I do things correctly, come back here. In my constructor, I should set up instance. I should just set up instance as null pointer. And I'll just put a nothing here for now. So I guess I was a little mistaken. I'm kind of a little ahead of the game here, but I can't do that, huh? Oh, shoot. Because, it's been a while here. The reason why I can't just go ahead and do this is, again, because instance itself is a static variable, and statics do not get initialized in constructors. They have to be initialized separately. So let me come up here, and so static variables get initialized as such. And so let's see, it's a singleton pointer. It is of type singleton. I just can't, it's hard to spell after a while. And it's called instance, and it's going to be initialized to null pointer. Let me move this all over a little bit here so we can see more. And that is how you initialize a static variable. And that's because everything that is static gets initialized prior to hitting the first line of code in main. Like all the statics get initialized before line 4 of main even gets hit and we start running the main program. So this is, because of that, there's a different syntax for this. So instance is going to be null pointer when the program even starts. So I would love to return instance, in this case when I do my getInstance function. However, it all comes down to the fact that when I return instance, I'm basically returning null pointer. And obviously if I try to return null pointer and then I try to do something with data that's sitting under the hood with a null pointer, the whole program is going to crash on me. So we need one if statement. If instance equals null pointer, then this is, because this is a public function and we're in the object, now I can call a private function. And so the private function is the constructor, and I can say instance equals new singleton. So the first time that this getInstance function gets called, instance is null pointer. So it'll go in here, go to line 9, and set up a new object, a pointer under the hood. And then it's all good, everything's done. And then when I get out of here, I'll return instance. And so the second time through, instance is no longer null pointer, so it will never create this a second time, and it'll just return the one true instance. And just for the sake of clarity, I don't 100% know, but since everything is static and things get a little weird, you probably should have a destructor. So I'll just put it in here. Can't hurt to not spell things right, but I'll have singleton as this, and I can go ahead. And it's a destructor is pretty much always public, because I don't even know if you can have a private destructor, because what would that mean? How could you ever not destroy an object, right? So all I'm going to do is delete instance and then say just for the sake of making everything work out, just say instance equals null pointer. Maybe I'm being overly cautious, but as I've become more professional over the years, professional me, right? You try to look out for things like this so you don't have dangling pointers and stuff like that. But that is essentially the entire structure here. There's nothing I can put in this here. There's nothing to set up that isn't non-static in the moment. The destructor destroys and then sets the instance to null pointer, so I don't have a dangling pointer. And everybody who gets instance gets the pointer they need. And so coming back here, there's really no easy way. Here, maybe I could put a print statement in here and say, or I could just run this through the debugger, and I could just say, let me set up singleton pointer, I'll just call it A, equals, and then how do we access this? Static functions get accessed differently than non-static functions, so I say singleton, say get instance like this. And so let me run our program now. I can, nope, no errors, good. Didn't do everything wrong. So I go ahead, I F10, and now I F11 in to this get instance function. And so now you can say instance is null pointer. You can see it right there. Instance is null pointer. So now because it's null, it sets up and it comes in and it does this. And now instance is it actually has a structure. We asked the operating system for memory, and now we have a new pointer to that memory, and we return that. So now the A is, oops, one more line here. A is pointing to that memory location. And now we can do the cool stuff with this. And every time, here, maybe I should do this a second time just to say A equals, just to say, try the same code twice. And let me put the breakpoint on line 7 now, because we've already made sure line 6 works. And so I go in a second time, and now instance is not null anymore. So it goes right through the if statement, and it returns that one instance. So pretty cool stuff. And let's discuss now what we can do, because this is the foundation for this. Now let's show what we can do with this thing, and then that'll end our video. So I was alluding to it earlier when I set up private member variables that were non-static, and that's exactly where we're going with this. This is just something you slap on to your regular class in order to get the behavior of only allowing one object of this type to exist throughout your system, throughout your entire the execution of your program. So what if, instead of this being singleton, think of this as like a video game. So like, video for me, I teach video games, I teach this and that. So and people know games. But so what if I were thinking about the resolution of the window of my game? And say there should only be one game that's running, right? Your game on the system. So it makes sense that maybe your game would be a singleton. And then in here under the hood, I could set up my width. I could set up my height. And then I can set up public. Let me just for the sake of this, just to make this simple, I'm going to set up, just to show you how things would work, and then, then the sky is the limit for you. I'm going to set up a public function that can get width. And I'm going to set up a function that can get height. So these are just normal getter functions, and these are returning ints because ints are my data types here. So coming back to my, setting everything up here, just to say here, now my constructor needs a little bit of work. My width, I'm just going to use 1920p resolution, so I'll just say 1920, and then I'll say my height is 1080. So that is what we have going for us in the public constructor, excuse me. And so there we go. So now when the constructor gets hit, my object is still initialized like every other time. My contract is to make sure I have no garbage data. And when the singleton gets called, there is no garbage data. Width gets set to something, height gets set to something, and I can get that information. And let me just now fill in these two functions. Go ahead here, oops, and go back over here. Return 0, nope. I can return width. I can return height. And I can spell it. There we go. And so now we have everything we need, when it comes to these two variables. So I can't just go and just say int x equals singleton : get width. If I try this, there's that error. Let me build it so you can see what error message comes up. And you can see a non-static member reference must be relative to a specific object. Don't you love the error messages? And get width, illegal call of non-static member function. So what I was saying earlier is you can only use this syntax to call static methods. And so this get width function is not static. It's non-static because the only part that needs to be static is everything that relies on the singleton to work. And so in this case, no, we don't want to just slap static on everything. He's like, I'll just make everything static. Well, then you're basically eliminating the design pattern for the singleton, and you're replacing it with what is called monostate. And it's not a terrible thing, but it's if you hate singleton, you are going to despise monostate. So just keep that in mind. So there's got to be a way to get to this function, and that's where the get instance comes in. So if I can't directly call this get with function from statically, I can do it by getting the instance, which gets me the actual class, and then because now that I have a pointer to a regular singleton object, now I can call the non-static function. So I can actually go ahead here and print out singleton : : nope, I can do singleton : get instance function arrow get with. Because remember, the get instance function returns me a pointer, and to be able to dereference that pointer, I have to use the arrow notation. And then I can say use the get with function, and it will, if I did this right, which I almost can guarantee at this point, I get where I need to get. Let me just put an end line here and just replace this. Oops. Copy paste this. And I can get rid of this guy. And I can say get height. And I can end line, and I can print this out. And now there is my 1920 and there is my 1080. So I have a static member variable under the hood, but I can get to I can make it non-static by calling get instance, and then I can call any non-static function using after I get the get instance. And a lot of times what you'll see here is something like this, because there's no reason to just keep pulling get instance, get instance, get instance. A lot of times you will see something like this. Something like this. Let me put a semicolon here, and then you can go ahead and just say instance arrow instance. That pretty much covers all the bells and whistles. And now the sky is the limit when it comes to just the basicness of this. If you needed to set up more functionality, you just treat it like normal. You just make everything non-static, and you just go to town on it. And as long as your user, whoever's using your code, gets the instance, they can do whatever they want with that instance sitting under the hood. All right. If you have any questions about this, as always, sward@cod.edu is a great way to get a hold of me. Comments here on YouTube are also a great way to get a hold of me. One thing I did not do was the shared pointer idea again that I'm getting from people across the world. I guess I'm doing things the more C way rather than the C++ way, but I also have to do things the computer science way when it comes to teaching the objectives that are a part of our curriculum. So thanks for sticking with this. I have a few other videos that I'll be making, at least in my time. It's my future. Maybe it's already done for you watching my videos for other design patterns. I'm trying to think of the other ones. I'm probably going to do strategy, flyweight, state and strategy are very similar, so you can think of it that way. And maybe a few others depending on how much time I have over the next week or so to set these videos up. If you have any that you'd like to hear, to learn about, hit me up and I'll see if I have some time to do it for you. Thanks as always. Have a great day. I'll see you next time.